on!
Where's my pen? Right back in, not even break.
Ammonia produces a pH of 10.2. Explain the pH with reactions. Okay, so acids will always produce hydronium ions. You want to kind of like manipulate it so that hydronium ion gets produced in there. It's useful for you to kind of see where the hydrogen got transferred. Okay, so this time ammonia. What's ammonia? NH3. Okay, so NH3 aqueous. Okay, so we always kind of put these together with water. Now, do we have to worry about a spectator ion here? No, okay? So this is still going to react with the water environment. Okay, so what do we want to kind of manipulate to produce here? Okay, so look at the pH. What type of substance is this? Acid or base? It's a base, okay? We want to produce a hydroxide, so watch what happens. Okay, so is it valid for us to say that hydroxide can get produced? Now, instead of this one giving the hydrogen to that water, guess what happens in the opposite direction? The water actually gives its hydrogen to the ammonia, and what's the other molecule that gets produced? NH4 positive 1. What? Science! Okay. All right. So right there, this hydroxide is going to give us a pH of a base, okay? So these are some of the things that you guys are going to be kind of like figuring out as you write out these formulas, okay? Let's try another one. Sodium acetate has a pH of 8.4. Did you want a different pH level?
Okay. 8.6, please.
I already wrote it. I don't like my notes messy. Okay, so first thing that you write is that sodium acetate is going to first do what?
Dissociate.
It's going to dissociate. So it'll break up into sodium and acetate. Okay, so between these two products from the dissociation, which one is going to be useful for us in an acid-base reaction? The acetate, okay? So could there be room for hydrogens to move around onto that acetate? Yeah, man, okay? Now, the sodium, typically the metal ion, is usually going to be called the what? Spectator ion, okay? So this is the spectator ion, doesn't participate directly in any sort of a reaction here, so it's just going to watch what happens, okay, before its eyes. So now, the second part to this, how are we going to show why is this a pH of 8.4. So this acetate is going to further react with the water environment. So now, what are we kind of looking to produce on the right-hand side? Should it be a hydronium or a hydroxide? A hydroxide. Okay? Kidding. Okay? So you look at the pH level, assess if it's an acid or a base, and then you kind of manipulate it so that whatever has to happen has to happen. Okay? So in this one here, the hydrogen comes from who? Does it come from here or does it come from the water? It comes from the water. Okay? So if you want, this is helpful for you guys for next year as well. If you want to show where the hydrogen has come from, it's really, really useful to do that. Just a good practice for next year, Chem 30, acid and base equilibrium stuff. Okay? So the other substance, once that hydrogen gets its way over here, the hydrogen positive 1 and then the CH3COO negative 1, what are they going to produce? Acetic acid. What? Craziness. Okay? Nope, no charge, right? Because if it takes on a hydrogen positive and it combines with a -1, it's going to be neutral, right?